In this video, we're going to discuss the common and natural logarithms. In particular, we're going to define both the common logarithm and the natural logarithm, as well as evaluating both of those types of logarithms. So we'll first discuss the common logarithm. The common logarithm is the logarithm with base 10. This is denoted by simply not indicating any base. So instead of a log with a base 10, we'll often just see a log of x. And just like with any other logarithm, we can rewrite it in exponential form. This is going to mean that 10 to the y is equal to x. The implicit assumption here in this logarithmic notation is that the lack of a base being written means we're in base 10. Everything that we know about logarithms and everything that's true about them will also be true about the common logarithm, since this is just one particular logarithm with one particular base, in this case 10. In this example, we want to evaluate y equals log of 1,000. Since this is the common log, which we know because there is no base listed, so we are assuming base 10, if we convert this to exponential form, we see that we have the equation 10 to the y equals 1,000. Since 10 cubed is equal to 1,000, the value of this logarithm is 3. And so common log, or log base 10 of 1,000 is equal to 3. For a second example, let's suppose we wanted to evaluate y equals common log of 1 over 100, or 100th. Again, because there is no subscript or no base listed here on the logarithm, we're assuming it's common log base 10. And so we want to solve 10 to the y equals 1 over 100. And here we can think of 1 over 100 as 1 over 10 squared. And in order to think of this as 10 to a power, we can use negative exponents. Because 10 to the second power is in the denominator, we can move it to the numerator as long as we make the exponent negative. And so this is equal to 10 to the negative second. By comparing the first and last term in this long equation, we see that y is equal to negative 2. So 1 over 100 is 10 to the negative second power. And so the log of 1 over 100, the common log of 1 over 100, is equal to negative 2. Common logs are used in a variety of real-world applications, including measuring acidity with a pH level, sound with the decibel scale, or here, earthquake intensity using the Richter scale. We're not going to be talking about the Richter scale in this example, but it is being used behind the scenes here. So in this example, we have the amount of energy released from one earthquake was known to be 500 times greater than the amount of energy released from another earthquake. The equation 10 to the x equals 500 represents a situation where x is the difference in magnitudes on the Richter scale. So behind the scenes for this equation 10 to the x equals 500, we have a Richter scale calculation going on. The question that we'd like to determine is what the difference in magnitudes in the Richter scale actually is. That is, in other words, find the value of x. So here we are given our situation modeled by the equation 10x equals 500, and we want to find the value of x. Since this is an exponential with base 10, we could convert this into logarithmic form. And when we do that, we see that x, the exponent, will be log base 10 of 500. And of course, log base 10 is the common log. Now, at this point, there are a couple ways that we could proceed. If we knew some log properties that we haven't discussed yet, this could be simplified a little bit more before having to resort to a calculator. But at this point, with what we know so far, the easiest way to do this problem is to simply just go to a calculator and use the common log button. Any scientific or graphing calculator should have a button that simply says log. Sometimes it's in lowercase, sometimes in capital letters, but there should be a button that says log, and you can use that followed by the number 500, hitting enter, and we should obtain a value that's approximately 2.7. Right, so it's 2.699 to go out a couple more decimal digits. but 2.7 is the approximate difference in magnitudes. What this means is that if we knew the smaller earthquake had a Richter scale reading of 3, the larger one would have to have a Richter scale reading of 5.7 in order for the difference to be 2.7. Another important logarithm base is the base e. And a logarithm with base e is called the natural logarithm and is denoted with ln of x. And so ln of x will equal y simply means that the number e raised to the y power is equal to x. So this is the logarithmic form of an exponential of base e. Just like with common log, all of the properties that we've discussed with logarithms also apply to this particular function because it is just a particular specific case of the general logarithm. To see an example where we need to evaluate a natural logarithm, let's look at this one. Here we want to evaluate y equals the natural log of the cubed root of e to the 5th. So as always, we start by converting this to exponential form, and since we have a natural log, we're going to have a base e. So the exponential form of this equation is e to the y is equal to the cubed root of e to the 5th. And so what we need to do in order to find the value of y is rewrite the cubed root of e to the 5th so that it is e raised to some power. And we can do this just by recalling some various properties of exponents. The first property that we need is to be able to rewrite the cubed root in terms of exponents. So e to the 5th is the number that we're taking the cubed root of, and the cubed root of some number is the same thing as raising that number to the 1/3 power. This is similar to the square root being the same as raising the number to the 1/2 power, or the fourth root being the number raised to the 1/4 power. Now once we have this, e to the 5th all to the 1/3, we have a power raised to another power, and a property of exponents says we can multiply those powers together, or those exponents together, to get the new exponent. And so e to the 5th raised to the 1/3 is the same thing as e raised to the 5 times 1/3 or 5/3 power. And now by comparing what we have here, we see that e to the y is e to the 5/3, and so y has to be 5/3. And so the natural log of the cubed root of e to the 5th is equal to 5/3, 5/3. Like the common log, the natural log can also be evaluated on a scientific and graphing calculator. There should be a button that says ln, and it works the same as the common log button. It will evaluate the natural log of whatever number is input. Being able to compute a common and or natural log on a calculator will become important when we go to solve equations and look at and particularly when we look at applications of exponential functions later on.